So there are two types of real numbers. One is called the rational numbers, while the other is called the irrational numbers. So let us understand what do you mean by rational numbers. Look at these examples. 7 upon 2 minus 115 upon 9, 23 upon minus 3, minus 8 upon minus 5, and 0 upon 143. What do you feel is common among all these numbers? So you might be saying that all these numbers are fractions, where there is a number over here in the numerator and there is a number over here in the denominator. And that's true. All these are fractions where there are two numbers. And both these numbers are either positive or negative. You can see numerator is positive or negative, and the denominator is also negative and positive, and numerator can also be 0. So the numerator are integers which are positive, negative, or 0. So they could be positive, 0, or negative. And the denominators are also integers. Again, denominators can be positive or negative. But remember, we cannot have a 0 in the denominator. So denominator cannot be equal to 0. The reason is because when we write 0 in the denominator, like let's say 7 upon 0, this becomes a meaningless number. Meaningless number. So we do not consider such numbers in rational numbers. So what are rational numbers? Rational numbers are nothing but the ratio. That's how this word rational comes. It's a ratio, or it's a division of two integers, one in the numerator and one in the denominator. But the denominator integer cannot be equal to 0. So you can have, let's say, 5. 5 is also a rational number, because if nothing is written in the denominator, we can assume that 1 is there in the denominator. So 5 upon 1 is nothing but 5, and similarly 5 is 5 upon 1. So in order to summarize this, if p is any integer and q is any integer, same or different, but q is not 0, then p upon q is said to be a rational number, and it comes from the word ratio. Now, if you convert the rational numbers from fractions to decimals, there are two decimal forms of rational numbers in the decimal format. One is the terminating type and the other is the recurring type. First, let us consider this terminating type. Terminating means it stops. The decimal representation stops somewhere or the other. For instance, let us divide this 97 upon 8. So we have 97 divided by 8. So 8 ones are 8. 1 remainder. 7 brought down. 8 twos are 16. 1 remainder. And then we can put a decimal point and we can take 1 0 at one time. Then we have 8 ones are 8 again. And then 2 remainder, 1 0 at one time. And 8 twos are 16. 4 remainder, 1 0 at one time, 8 fives are 40. So the remainder now becomes 0. So we have this answer, 12.125, and we end up with having a 0 as the remainder. So this division stops, means we have this perfect answer called 12.125. And there are no other decimal places after this, means there are no other digits after this. So it stops somewhere or the other. So such a type is called the terminating type. Similarly, if I take 1 upon 2, so if I divide this in the corner, 1 upon 2, always write this 2 outside. So we can start with 2 zeros are 0, and 1 minus 0 is 1. Put a decimal point, write a 0, 2 fives are 10, and we have 0 as the remainder. So 1 upon 2 is 0.5, and this also belongs to this terminating type. Let us take another example, 12 upon 5. So 12 divided by 5, 5 2s are 10. Then we have 2 as the remainder. We put a decimal point, 1 0 at one time, and 5 4s are 20. So this also stops. We have this perfect answer 2.4. There are no sets of digits repeating continuously. So we have this 2.4, and this is also a terminating type. We always get terminating types whenever this denominator has prime factors in terms of 2 or 5. If 2 and 5 are the prime factors, or both sometimes, then only we have this terminating type. Terminating type. For example, in this particular example, 97 upon 8, we saw that if we factorize this 8, we get 2 multiplied by 2 multiplied by 2. And since the prime factors are in terms of 2, or sometimes it could be in terms of 5 also, or sometimes both also, then we have this terminating type. And then the second type is the recurring type. So if we divide this 20 upon 3, we have 3 6 are 18. Then we put a decimal point, and we can put 1 0 at one time. We have 3 6 are 18. And again, we see the remainder is 2. We put a 0, 3 6 are 18. And if we see that always we get the same remainder 2. And this will go on endlessly, 6.666666, etc. So we never get a remainder 0, and this is a recurring type. Recurring means it keeps on repeating itself. So that digit or a set of digits, they repeat continuously. We can rewrite this as 6.recurring 6. So this is a recurring type, but remember, this is also a rational number. Why is it a rational number? Because we have an integer in the numerator and we have a non-zero integer in the denominator. Similarly, 5 upon 7 is also a rational number. But if we divide this, let's see what we get. So we have this 5 upon 7. So we start with 7 zeros are 0. Then we have this 5. We put a decimal point and 1 0 at one time. Then 7 7s are 49. And this time we get 1 as the remainder. We put a 0. 7 1s are 7. 3, putting a 0. 7 4s are 28. 2, putting a 0. 7 3s are 21. So 7 2s are 14. 6, putting a 0. 7 8s are 56. You might be thinking this will go on and on and on. Let's see. Then we put a 0 again. 7 5s are 35. I'll just write it over here. 35. We get 5. You may have observed we had 5 over here also. And then again we have a 0. And we have 7 7s are 49. Which actually was present over here also. So you can say that, comfortably speaking, that this answer would be 0.714285, and again it would be a 714285. So we can say it is entirely recurring from 7 to 5. So remember, rational numbers can be written as a fraction where p and q both are integers and q is not equal to 0. And the other way we can identify whether it's a rational number or not is that it stops in decimal format. Means 2.5 or 2.53 is also a rational number. And if we have 2.53 recurring, then even then that's a rational number. Or this 5 3 entire recurring will also be a rational number. I hope you understood this. Thank you for watching.